Hi, welcome back to Applied Algebra. We are moving on in Chapter 9, Section 2. In Section 1, we worked on solving linear systems by graphing, and in Section 2, we're going to use a method called addition, or sometimes you may hear it called elimination, which is a little bit more common. Our textbook uses the word addition. So in the first section, we solved the equation or the system x plus y equals 1, 2x minus y equals 4. We graphed it, we found out where they intersected, and we found the point of 1.5 and negative 0.5. So we're going to do it with the second method this time, and the idea here in this method is you want to line up your variables. So you can see the way I have it written, your x's are lined up, your y's are lined up, equals are lined up, and your constants lined up. You want to make sure that the y's or the x's, one of them has an opposite sign. So either the x's, one has to be positive, one negative, or on the y's, one's positive, one negative. The second thing you want to check is that they have the same number. So if you look at the x in this problem that we're focused on, the top one is a 1, the bottom one is a 2. But the y's, they both have a 1 and a negative 1. So they are both using the number 1. So what we're going to do is we're going to keep them there, and I'm just going to rewrite it. So I have x plus 2y equals 1. I have 2x. Why did I write a 2 there? Let's get rid of that 2. I don't know why I put a 2 there. I have 2x minus y equals 4. Now, in the addition method, and then the reason our book calls it the addition method is because I'm always going to add these two equations together. So I'm just going to add the x's, I'm going to add the y's, and I'm going to add the constants. So x plus 2x is 3x, and I'm actually going to write it over here. A positive y and a negative y eliminate because they're gone, and so that's why some books call it elimination, equals 1 plus 4 is 5. Now I have an equation where I only have one term, so I'm going to quickly divide. To get x by itself, I'm going to divide by 3, and so I end up with x equals 5/3. Now I'm halfway done, and notice that's not quite what we got before, but we had to do the best we could with graphing because it's hard sometimes to get an exact answer. Well, we have an exact answer. 5/3 is 1.6 repeating. It's more exact. To find the y now, I'm going to take that x and I can choose to plug it either into the top equation or the bottom equation. It truly does not matter. So I'm going to go ahead and just stick it into the top one. So I have 5/3 plus y equals 1. And my job is to solve for y. So if I want to get y by itself, I have to move the 5/3. Since it's a positive, I'm going to minus the 5/3 to both sides. So I end up with y equals 1 minus 5/3 is negative 2/3. So my exact answer that I just came up with is 5/3 and negative 2/3. Now if we look at the answer that we got with our factoring, that's really close because our factoring was 1.5 and negative 0.5. But we just did the best we could with the graph that we had. It'd be really hard to get 5/3 and negative 2/3 with graphing. So this kind of shows us that some methods might be better as far as getting exact answers if the numbers or the answers themselves are not whole numbers. So let's go ahead and try the next one. We're still going to stick to this idea of addition. I want to look at them and I say, okay, well, neither the x's or the y's have an opposite sign. They're both positive in both cases, so it's truly up to me on who I want to do. So I'm going to choose to do opposite signs on my x's. Okay? Now to do that, I'm just maybe going to do an opposite sign on the bottom one. I'm going to be able to do that in a moment. Notice they also don't have the same number. The top one has a 3, the bottom one has a 1. I can make the bottom be a 3 if I multiply it by a 3. So if I multiply the bottom by a negative 3x, not only will they have opposite sign, but they will have the same number. Now, here's the kicker. If you do it to the first term, you also have to do it to the second term and to the third term. We have to make sure it stays an equation, it stays balanced all the way across, so I have to distribute and do it to everybody. So I'm just going to rewrite the top one, 3x plus 2y equals 10. The bottom one I'm going to multiply by -3, so I get -3x. -3 times 5 is minus 15. Y equals -3 times -27. -3 times -27 is 81. Now, remember it's addition because we add like terms. So I'm going to add the x's, add the y's, and add the constants. So in my x's, they're gone. I have 2y minus 15y, so I get -13y. I have 10 plus 81, which is 91. So I'm going to go ahead and get my y by itself by dividing by -13. And so 91 divided by -13 is -7. So y is -7. Now that I have y, I want to go ahead and still find x. Now remember, just like in the first system, it doesn't matter who you plug it into. I can do it in the top, I can do it in the bottom. I tend to just see if the answer works better with a set. It's not really going to matter which one. I'm going to go ahead and just do the bottom and mix it up. So I'm going to do x plus 5 times -7 equals -27. Now as you're doing it, you might find little things that make life easier for you, so just practice going back and forth and see which ones you like. 5 and -7 is minus 35. I need to move the 35, so I'm going to go ahead and add 35 to both sides. And so I end up with x equals -27 plus 35 is 8. So my answer is 8 and -7. And again, I don't know if you noticed, I've been writing these as an ordered pair. Just like we did in the graphing assignment, I want to keep that going. Okay, so the next one, I noticed my x's don't have the same number. My y's don't have the same number. Neither one of them have opposite signs, so I'm going to have to make that occur again. On the last one I made, which one did I make? On the last one we made the x's be this opposite sign, so let's just mix it up and make the y's be the opposite sign this time. I lost my pen, just a second, I gotta turn my pen back on. Okay, so if we're going to make the y's be the opposite sign, there it goes. So we're going to make these be opposite sign. Again, I'm going to either do the top or the bottom. I'm going to choose to do the top, and I'm doing the top because I'm going to have to change that top number anyway. I can change the 4 and multiply it by a 2, that'll make it become an 8. If I were to go the other way and take half of 8 and make it be 4, it might be crazier. So it's up to you. I can either divide the bottom by 2 or multiply the top by 2. I'm going to multiply the top by a -2. That looks really bad, so let's try that again. So -2 we're going to multiply by. So my top's going to become 4x minus 8y equals -16. My bottom is still, because I haven't done anything to it, -4x plus 8y equals 12. So we're putting together things that are the same. Our x's, our y's, and our constants are all going together. In this case, my 4x minus 4x, my x's cancel. My -8y plus 8y cancel. Now that has not happened before. So what ends up on this left-hand side, I don't have anything left, so I'm just going to put the number 0 there. I would double check, make sure I didn't multiply anything wrong, negative and a negative. So just a quick double check, I did do every multiplication right. -16 plus 12 is -4. So I would make sure I didn't write the problem down right, make sure I did my multiplication right, I did all of that correct, so this is my answer. Now, is this a true statement? Is 0 equal to -4? There is no way that is a true statement. If this is a false statement, then there is no solution that will make these two will never cross each other. And if you think about the graphing section, that did happen. We did have systems that never crossed, and if you remember, those were parallel lines. So graphically, this is what parallel lines look like when you're solving it algebraically. So if you get a number equaling another number, so they're not the same number, that's a false statement, and you will get no solution. Okay, let's check this one out. So let's go ahead and just try a division just to see what it's like. So nobody's got the same number, nobody's got opposite signs, so I get to pick whichever one I want. I'll just do the front one. And I'm going to mess with the bottom one, and instead of multiplying, I'm going to divide this by -3. I noticed that all of them are divisible by 3, and if I do that, the 9 will end up at a 3. So just to show that I can, I'm going to go ahead and do that. The top one's not changing, so I'm going to rewrite that. 3x plus 6y, kind of looks like a B. Let's try that one again. 6y, it's a little bit better, equals 8. And now I'm doing the division, remember. So the bottom is 9 divided by -3, that's -3. 18 divided by -3, that's -6. 24 divided by -3, that's -8. That looks kind of interesting. I'm going to put my x's, my y's, and my constants. 3x minus 3x is nothing. 6y minus 6y is nothing. 8 minus 8 is nothing. So this time it's a little bit different. I end up with 0 equals 0. Well, that is a true statement. 0 is equal to itself. If it's a true statement, those are infinite solutions. So these are the cases where I have coinciding lines, where one is directly on top of each other, so I have more solutions than I would know what to do with. I have tons to choose from, so I have infinite solutions. So I can end up with this scenario with infinite solutions. I can end up with no solution, or I can end up with a point that actually occurs. So this is our second method in solving systems, which is the addition or elimination method, depending on what you want to call it. Go ahead and work on the assignment. When you get it done and you want to upload it, go ahead and do so, and I will get it back to you as soon as I can. Have a good day.